This is another unknown question from one version, one permutation of one of the midterms for section 1. So I'm calling it question 5 here. But in any case, it's basically the same as one of those Bayesian network counting the number of CPTs question. So I'm going to just do it again here. So in particular, it is a naive Bayes. So we have a Y here. There are two classes, which means Y can be either 0 or 1. And Y is the parent. Basically, Y generates all of these X's. That's why it's called naive Bayes. It's a generative model. We use Y to generate X instead of X to generate Y. So that's why Y is the parent of all of these. How many features? There are 3 features, X1, X2, and X3. Each one has 4 values, so 0, 1, 2, and 3. So the same for X2 and X3. So the question is, how many of these CPTs do we need? So first, many people forgot that we need the CPT for Y. So we need the probability of Y is 0. So we need to estimate that. We don't need to estimate the other one because that other one is just 1 minus that. It's 1 minus probability of 0. So in general, if there are K classes, then you need K minus 1 here, and here it's just 1. And for each X need to take on 0, 1, 2, not 3, because 3 is 1 minus all of these things, given Y is 0, given Y is 0. So there are 6 of these, and you also have another 6, Y is 1, Y is 2, Y is 1, Y is 1, and Y is 1. So note that these two sum is not equal to 1, because they are given different Y values. So they are not related in any way. But these 3 plus this 3 given Y is 0, these 4 must sum up to 1. Because this is the probability of X being one of the 4 values, and there are only 4 values. So of course, if you add them up, it should be 1. So in total, we need basically 4 minus 1, which is 3. There are 4 values minus 1 because we don't need the last one, multiplied by the number of things that we need to be conditioned on, which is 2 here. So if we add up these two, and also we have 3 different variables, right? I almost forget that. We have 3 different variables, so if you add them up, then you can get the answer here. That's the total number of probabilities you need to estimate or you need to store in the CPTs.